Hey everyone, and welcome to today's Explainer. Today we're diving headfirst into a massive shift in how we work, and more importantly, how we protect that work. We're going to be looking at securing the modern enterprise browser, specifically breaking down a really unique architecture from Seraphic Web Security. If you're in IT, cybersecurity, or honestly, if you just care about keeping your organization's data locked down, this is absolutely for you. Let's get right into it.
Okay, here's our roadmap for today. We'll start with the new enterprise workspace, move into the blind spot problem, then break down the architecture and deployment. After that, we'll look at the 4 engines of protection, see how it handles stopping real-world attacks, and finally, wrap up with the frictionless user experience.
All right, Section 1, the new enterprise workspace.
Okay, let's dive right into this idea. Business happens in the browser. I mean, it sounds simple, right? But the implications here are massive. Think about it. The web browser isn't just a tool for looking things up on the internet anymore. It is the default enterprise workspace. It's literally where remote teams collaborate, where contractors get into corporate apps, where we do research, and where we're leveraging all these new AI tools. Practically everything at the organizational level has been pushed to the browser. But here's the catch. Despite being the absolute frontline of our productivity, standard enterprise browsers are really lacking when it comes to essential enterprise-grade security.
And man, the data illustrates this risk perfectly. Because the browser is the #1 application being used, digital predators are, well, they're following us there. An astonishing 76% of ransomware hacks and 70% of malware attacks are now originating straight from the web. To put that into perspective, that's more than 3/4 of ransomware. Plus, in a span of under 2 years, hackers exploited 15 browser-oriented zero-day attacks. The browser has rapidly turned into a major vulnerability for enterprises and a prime source for compromised endpoints and sensitive data loss.
Moving on to Section 2, the blind spot problem.
So what's going wrong here? Well, it really comes down to visibility. You know the saying, you can't protect what you can't see. And traditional security tools like your EDRs, SSEs, and firewalls, they just weren't built for a world where all the action happens inside the browser. They operate way out at the endpoint layer or the network layer, which basically leaves the internal operations of the browser as this massive, glaring blind spot. Seraphic Security takes a completely different, totally transformative approach. Instead of relying on limited vendor APIs, Seraphic operates deep inside the browser's native JavaScript engine. It overlays the native interpretation engines, which means it can monitor, separate incoming code, and actually control all browser operations natively from the inside out.
Which brings us to Section 3, architecture and deployment.
Let's look at exactly how they deploy this, which happens in 4 pretty straightforward steps. Step 1, the user just browses the web as they normally would, connecting to internal apps, SaaS platforms, public sites, the whole shebang. Step 2 is where the magic happens. The Seraphic agent gets injected into the session. Now this can happen via a normal browser marketplace extension like on Chrome or Firefox, or through a super lightweight inline proxy, which is actually perfect for external users routing into your internal apps. Step 3, all the processing and policy enforcement happens locally, right there on the client's machine. And finally, Step 4, only the alerts and the policies themselves are synced back up to the Seraphic AWS Cloud Backend Management Console.
Now, I really want to point something out about this setup. The local client-side processing. This is a real game changer. Because Seraphic pushes the logic down to the device itself, literally 0 user data is transmitted to the cloud for analysis. None. This solves 2 huge problems. First, privacy. Sensitive data stays completely away from third parties. And second, efficiency. By processing everything locally, you totally eliminate that frustrating network latency you'd normally get if you had to route all your web traffic to a cloud server for inspection and then back again. It's fast and it's completely private.
Okay, let's jump to Section 4, 4 engines of protection.
Before we get to the engines themselves, we really need to wrap our heads around a vital concept here, chaotic manipulation. So here's the deal. Attackers rely entirely on predictability. When they build an exploit, they are banking on the browser's JavaScript engine reacting in a very specific, deterministic way. Seraphic uses a patented process called chaotic manipulation that basically jumbles up the execution flow and API invocation of the JavaScript. So the attacker's code hits this completely unpredictable environment and just fails. It's kind of like trying to follow a precise baking recipe, but all the ingredients keep teleporting around the kitchen. By breaking that predictability, you completely neutralize known vulnerabilities and, even more incredibly, those totally unknown zero-day exploits.
With that in mind, let's see how the 4 core engines build on this tech.
The first two are all about security. First up, the prevention engine. This uses that chaotic manipulation we just talked about to stop exploits absolutely dead in their tracks. Next is the detection engine, which uses real-time context-based telemetry to spot and block things like phishing, cross-site scripting, and HTML smuggling. Then, the next two engines focus on governance. The policy engine enforces data loss prevention, or DLP. Depending on what the admin sets up, this engine can mask sensitive data on the screen or restrict user actions for specific domains. I mean, it can literally block a user from taking a print screen, copying text, or uploading a file. Crazy, right? Finally, we have the management engine, which monitors for risky browser extensions, blocks the malicious ones, and pings the necessary alerts back to the admin console.
Moving into Section 5, Stopping Real-World Attacks. Let's pose a question to you all. What actually happens during a clickjacking attack? Well, it's a very common, very sophisticated social engineering technique, and it perfectly illustrates why we absolutely need this deep browser visibility. Imagine a user navigating to their normal Okta login page. Everything looks perfectly fine, but an attacker has snuck in an invisible iframe, essentially a hidden, transparent overlay right on top of the login fields. So when the user starts typing their username and password, they aren't typing them into Okta, they are typing them directly into the attacker's invisible trap. Traditional security is completely blind here, because technically, the user is on a legitimate site. But since Seraphic is monitoring the actual operations deep inside the browser, it instantly spots this hidden overlay, throws up a web security alert, and completely blocks the user from handing over their credentials. This also shines a light on another massive headache for IT: unpatched browsers. In a lab demo, accessing a malicious URL with an unprotected, older version of Chrome, we're talking version 93 here, allowed an attacker to pull off remote code execution. They proved this by forcing the local system calculator to pop up on the screen, which basically means the whole device was compromised behind the scenes. But, and here's the cool part, when that exact same URL was accessed using the exact same older version of Chrome, but this time protected by Seraphic, the attack was instantly detected and the exploit was totally blocked. Seraphic essentially acts as this amazing safety net. It allows organizations to thoroughly test new browser updates internally before rolling them out, without leaving their users completely exposed in the meantime.
And finally, Section 6, the frictionless user experience. A common problem with traditional security tools is that they force this clunky, frustrating experience on the user. The source material points out that Seraphic completely sidesteps this by adding its security layer directly to the browsers people are already using, whether that's Chrome, Safari, Edge, or Firefox. There is literally zero friction because there's no clunky new enterprise browser to learn. It also fully supports BYOD, bring your own device, through a proxy deployment, so remote contractors can get access without needing a permanent installation. Plus, it has full single sign-on integration with identity providers like Okta or Azure, making it super easy to tailor policies to specific groups. And interestingly, the protection is mandatory. It keeps right on working even if a user tries to be sneaky and bypass it by opening an incognito window. Lastly, for organizations still chained to legacy apps, it can even protect older browsers like Internet Explorer, safely extending their lifespan before you're forced to migrate.
So, as we wrap up, I want to leave you with this provocative thought. Is your enterprise's most critical workspace currently operating in a complete security blind spot? As we've explored today, the browser has essentially evolved into the operating system of the modern business, but our traditional defenses just haven't kept pace. Solutions that move security natively into the browser itself are totally redefining how we think about risk and productivity. I really hope this breakdown gives you a clear, structural understanding of how modern browser architecture is being secured today. Thank you so much for joining me for this explainer, and keep asking great questions.